Hello everyone. In this video, we will learn about conflict serializability in transaction management. So before going on to what is meant by conflict serializability, you should know what is a schedule. Schedule is a series of operation from one transaction to another transaction. So basically it is used to preserve the order of operation in an individual transaction. So schedule can be a serial schedule, it can be a non-serial schedule, it can be a serializable schedule. So we will see what is a serial schedule. So serial schedule is a type of schedule where one transaction is executed completely before starting the another transaction. So as you know that there may be so many transactions happening. So serial schedule means one set of transaction will be executed completely before starting the another transaction. So in a serial schedule, when the first transaction completes its cycle, then the next transaction is executed. Suppose we have two transactions T1 and T2. So that means that we will be executing all the operations of T1 and then all the operations of T2 will be followed, or it can be in another way that it can execute all the operations of T2 and then all the operations of T1 will be followed. So either two possibilities are there. So here a non-serial schedule means there will be some interleaving operations. So if interleaving operations are allowed in between a transaction, in between transactions, then that is a non-serial schedule. So it may be it contains many possible orders in which system can execute the individual operations of the transactions. So in serial schedule, what happens is the one set of transaction completes, then only the next set of transaction another transaction starts. In non-serial schedule means some set of transaction will happen in transaction T1 and then some will happen in T2, then again it will come in T1, like that. So interleaving operations are allowed in non-serial schedule. So for example, we can see here this is schedule A. So in there are two transactions, you can see here T1 and T2. So in T1 there is a read operation, then A is updated, then we are writing the value of A, then read operation is performed, then we are updating the value, then writing the value of B. So as you can see, when we are seeing this transaction T1, there are no operations which is happening here in T2. So once this T1 T1 transactions are over, all the operations in T1 is over, then only T2 is starting. You can see here in T2 read A, then A is equal to A is updating, then we are writing the value of A. So all the operations in T1 is performed or executed, then only the operations in T2 is executed. So here in schedule B, in this example, you can see that first T2 operations are performed. So once all the operations in T2 is performed, then only the operations in T1 is performed, executed. So here also you can see there are no in between operations which is happening. But in this one, in schedules C, in this third one, schedule C, if you see T1, we are starting with read operation, then A is updated, and before writing A, we are going on to second transaction. So here in the second transaction, we are reading the value of A and A gets updated, and this A value gets updated, and then we are writing the value of A in T1. Then we are reading B and writing the value of A here. So you can see there are interleaving operations. So it is like before this transaction T1 is executed completely, there are the transaction T2 starts. So there are interleaving operations between T1 and T2. So hence this is a non-serial schedule. This is a type of non-serial schedule. Even here in schedule D, you can see here this T1 there is a set of operations, then we have again T2 there are set of operations, and here we can see there are interleaving operations between T1 and T2. So here in this four examples like A, B, C, D, we can see A and B represents serial schedule and C and D represents non-serial schedule. Now, what is meant by serializable schedule? So we have already seen what is serial schedule. It is like once this transactions in T1, all the operations in T1 is executed, then only T2 will start, or all the operations in T2 perform first and then T1 will start. There won't be any interleaving operations. So here serializable schedule means if we can make this non-serial schedule into the serial schedule, then that means it is a serializable schedule by swapping. So if we can swap this these operations and make this one serial schedule, then the serializability of schedules is to find non-serial schedules. So actually we can find some non-serial schedules that allow the transaction to execute concurrently. So in this case, what is happening is two transactions are happening concurrently. In non-serial schedule, you can see concurrent transactions are happening, but in serial schedule, you can see the concurrent transactions are not occurring. Only when one transaction is over, then the next transaction is starting. In the case of non-serial schedule, concurrent transactions are happening. So in serializable schedule means it is to find non-serial schedules that allows the transaction to execute concurrently without interfering with one another. If there is no interference between the two transactions, then we can say that it is serializable. So we will be finding which schedules are correct when execution of transaction having interleaving of this operation. So a non-serial schedule will be serializable. So how can you say a non-serial schedule? We can say a non-serial schedule is serializable if the final result of this one is same. If the final result of non-serializable schedule is same as a serializable, same as a serial schedule. So a transaction is said to be serializable if the result of a non-serial schedule is same as a serial schedule. So that is like so what is the serializability? So serializability is like, as you know, that each transaction preserves database consistency. So a serial execution of set of transactions, as you know, that it should preserve the consistency of database. So when we say that a schedule is serializable, then it is equivalent to a serial schedule. Serializable schedule means it is equivalent to a serial schedule. So we can have various forms of schedule equivalence. One is called as conflict serializability. Another one is called as view serializability. So we will see what is this conflict serializability. So what is meant by conflicting instructions? So suppose we have, as you have seen in this transactions, there are various instructions. These are all called instructions. These are instructions. So T1 is transaction, T2 is transaction, and these are all instructions. Suppose we have two instructions, I and ij. So in that two instructions in two transactions, ti and tj. So we can say that these instructions are in conflict if there exists some item q accessed by both the instructions. In as you know that the instructions I and ij belongs to two separate transactions, ti and tj, and these instructions will be in conflict if they are accessing the same item q, and at least one of these instructions will have a write operation. So if two instructions we have in both the transactions, and if both the transactions are accessing the same item, and if any of this instruction has a write operation, that means they are in conflict. So if two instructions are said to be in conflict if this any of this condition satisfies. So you can see this one, if one write operation is there means then it will be in conflict. Suppose I is read q, the same time the second instruction in transaction tj is again reading, but since it is both a read operation, then that means that this instructions doesn't conflict. As I already said, if two instructions are said to be in conflict only if they are accessing the same item and if there is a write operation. So here, if since even though they are accessing the same item, but there is no write operation, both are read operation, hence this I2, I and ij are not in conflict. In the second case, if you see, ii is read and ij is write, and both are accessing the same item. In the second case, this is in conflict because there is a write operation, because these two instructions will be in conflict if there is a write operation for the same item. So here they are in conflict. In the third case, you can see here it is a write queue and here it is read queue. So here again a write operation is there for the same data item. So they are in conflict. The fourth case is both are right and obviously it will be in conflict. So any of these conditions if it occurs, then you can say if there is a write operation for the same data item, then they will be in conflict. If both of the instructions in both the transaction, if they are having only read operation for the same item, then they want conflict. So a conflict between this I and ij are consecutive in a schedule and they do not conflict, their results would remain the same. So if they are if these instructions are consecutive in a schedule, and if there is no conflict in between, no conflict means if there is no write operation, that means that their results will be the same. So basically we can interchange the swap the schedule also, because the result remains the same as there is no write operation. So what is mean by conflict serializable schedule? So we can say that conflicting operations, as I already said, that when you will be saying two operations are in conflict, one is both belong to separate transaction. Then second thing is they have the same data item. So there should be two different transaction, then the item should be same, then they contain at least one write operation. So if these three things are there is in conditions, then we can say they are in conflicting operation. So if these three conditions are satisfied, then we say that those operations are in conflict. That is, they belong to separate transaction, they have the same data item, and they should have at least one write operation. Now let us consider an example here. So in this particular case we have two schedules, schedule S1 and schedule S2. So in schedule S1 we have two transactions. In transaction T1 we can see the first operation is read A. So in transaction T2 the first operation is read A. So here in this case we can see that there are no write operations, so that it is just reading the operation. So even if you change this read, if you swap this read with, first I can make T2 read, and here if you see in the order we can see that first in transaction T1 this read A is happening. Suppose I am making the transaction T2 the first read A, if I just swap this one, then also there won't be any change in the final result. You see here when I swap this one, T2 is first read, then T1 is reading, but there is no write operation here, so we can say they are not in conflict. So here S1, this schedule S1 is same as schedule S2, because even if we swap this read, they remain the result remain the same. So here S1 is equal to S2. This means there is no conflict. Let us see another example. Here in this example we have two schedules S1 and S2. But in transaction T1 you can see there is a read operation, and in transaction T2 there is a write operation. So what is happening is, first we are reading the value of A, then in transaction T2 we are writing the value of A, we are saving the value of A. So suppose when we swap this one, what will happen is we are writing the value of A first, and then we are reading the value of T1. So this is not true, same. So suppose the value will be changing, because we are reading a value of A in transaction T1 and we are writing it into transaction T2. But in this case we are already writing the value of T2 and then we are reading. So this schedule S1 result is not same as schedule S2 result. So S1 is not equal to S2. This means there is a conflict. So we have already seen that the conflict happens if there is either one write operation is performed for the same data item. So here this is an example for conflict situation. So what is mean by conflict equivalent? So conflict equivalent means we can transform one to another by swapping non-conflicting operations. Non-conflicting operations, if we can transform one schedule to another one by scheduling transaction one transaction to another transaction just by swapping non-conflicting operations, then we can say that it is conflict equivalent. So here in that example, here in the first example, this S1 is conflict equivalent. Here in this one we can say that is conflict equivalent to S1. S1 can be converted to S2 by swapping non-conflicting operations. So we can say two schedules are said to be conflict equivalent if and only if they contain same set of transaction. They should contain same set of transaction, and if each pair of conflict operations are ordered in the same way. So if all the conflict operations are ordered in the same way, then we can say that it can be conflict equivalent. So what is conflict serializability? So a schedule can be transformed. Suppose a schedule S, if we can transform that schedule S to another schedule S dash by a series of swaps of non-conflicting instruction. That means we have one schedule S1. Suppose we can transform that schedule S to some other schedule S dash by swapping non-conflicting instructions. Then we can say that S and S dash S are conflict equivalent. So a schedule S is conflict serializable if it is conflict equivalent. So how we can say a schedule is conflict equivalent? If we can transform one schedule to another schedule by swapping non-conflicting instructions, then you can say that it is conflict equivalent. If a schedule is conflict equivalent, then that will be conflict serializable also. So we can say a schedule is conflict serializable if it is conflict equivalent to a serial schedule. So a schedule is you can say that it is, if a schedule is called conflict serializability, if after swapping of non-conflicting operations it can transform into a serial schedule. So basically what is happening is, serial schedule, as you know that one set of transaction will be performed, executed first, and then another set of transactions in the next transaction. So non-serial schedule means there will be interleaving transactions. A schedule is conflict serializability means if we can swap this non-conflicting operations and we can transform that schedule to a serial schedule, then you can say that it is conflict serializability. So here, for example, we can just see here, this is schedule S1. So here in this particular case for transaction T1 there is read and write operation. Then we can see that before this is getting over, the transaction T1 is getting over, there are some interleaving operations because T2 is starting, then again T1, then so there are interleaving transactions happening in the schedule S1. So let us see schedule S2. In this particular case you can see T1, you can see once this T1 transactions operations are getting over, then only T2 is executed. So we can easily say that this schedule S1 is non-serial schedule and schedule S2 is serial schedule. Now what we can do is, we can convert this non-serial schedule to a serial schedule. How we can do that non-serial schedule to a serial schedule? By swapping non-conflicting operations of S1. So you can just see here what all operations we can swap here. So here if you see in transaction T1, first two operations are read A, write A. Then in T2 you can see read A, write A. So in transaction T1 we can see that next operations coming is read B and write B, and this is occurring before the read B and write B of transaction T2. So even if we shift this read B and write B before this transaction T2, the outcome will be, the result will be the same, because nothing is going to change, because this is not affecting. So this is a non-conflicting operation. So what we can do is, instead read A, write A, after this we can put this read B and write B, because it is non-conflicting here with transaction T2. So we just shift this up here, and then we can continue with read A, write A, and read B, write B. So here, when after this swapping of non-conflicting operation, you will be getting the schedule S1 like this: read A, write A, read B, write B. So here then T2. So here in this particular case you can see all the operations of T1 is executed, then only the transaction, all the operations of transaction T2 is executed. So here this, what we have done is, the non-serial schedule we have converted to a serial schedule, and this S1 is, you can say, hence we can call the schedule S1 as conflict serializable. So this is called conflict serializable. We have converted it into a serializable schedule. Now another one which we can't convert it into this one as serializable, suppose we have a transaction T3 and T4. In T3 we have the operations read Q, but you can see there are interleaving operations. In T3 first is read Q, and T4 we are writing the Q operation. What does it mean? We are reading the Q here and write operations of Q. that we are saving that value of q in this transaction T4, then we are writing the value of q here. So you can see that a write operation is occurring. So basically we can't shift this write operation of this one here to here in this transaction T3, because after this read queue there is a write queue, that is the same data set is used by transaction T4. So you can't swap this here. So this schedule is not conflict serializable because we are unable to swap the instructions in. We can't swap this instructions to obtain a serializable schedule T3 T4 or T4 T3. We can't swap this to get a serializable schedule. Hence it is called not this example is not conflict serializable. Now, how will you test for the conflict serializability? So if given a schedule on the transactions, we can test for the conflict serializability by means of precedence graph. So what we can do is when the transactions are given, we can draw a graph and precedence graph, and if the graph is acyclic, then you can say the schedule is conflict serializable. So by means of the graph, we can test the conflict serializability of a schedule. So a schedule is conflict serializable if and only if the precedence graph is acyclic. Acyclic means here in this particular graph, you can see this arrow is from Ti to Tk, then from Tk to Tm. You can see if there is Tm to Tj and Tj to Ti, then you can say it is cyclic. But here it is Ti to Tk and Tk to Tm. But from Tm to Tj is not, there is no path. So here this is not cyclic. So this is called an acyclic graph. So a precedence graph is acyclic, then we can say that the serializability is conflict serializable. Schedule is conflict serializable. Then we can even from this graph we can find the serializability order also. Like it can be either Ti, the order may be Ti Tj Tk Tm, or Ti Tk Tj Tm. If you go like this, Ti Tk then Tm, or Ti Tj then Tk Tm, Ti Tk Tj Tm, or Ti Tj Tk Tm. So any two order is only possible in this particular example. So let us consider an example how we will be checking the conflict serializability. So as I said, we can use precedence graph to check the conflict serializability. So how will you check the conflict serializability? So what we have to do is a given set of transaction. Let us take for each transaction Ti, we have to put a node or vertex in the graph. So for every transaction, we will be putting a node or vertex in the graph. Then for each conflicting pair, put an edge from Ti to Tj. So if there is a conflicting pair, then we have to draw an edge connecting from Ti to Tj. So if there is a cycle in the graph, then the schedule is not conflict serializable. If there is no cycle in the graph, then you can say the schedule is conflict serializable. So so testings how we will be doing is like, suppose you have a schedule S, then what we do is we will be constructing a graph called as precedence graph, and this graph will be having a pair VE, that V consists of set of vertices and E consists of set of edges. So the set of vertices is used to contain all the transactions participating in the schedule. So we will be having as many vertices as that many transactions present in the schedule. So the set of edges is used to there will be so you will be first making the vertices corresponding to the transaction. Then what we do, we will be forming the edges, but edges are formed only if these conditions are holding. That is, we will be creating a node Ti and we will be joining it with Tj, another node Tj, only if Ti executes write operations before Tj executes read queue. This is one condition. Second one is, we will again join this Ti to Tj if Ti execute read operation before Tj execute write on the same data. Or we can say if Ti executes write before Tj executes write queue. So we will be forming an edge from Ti to Tj only if there is a write operation that Ti executes before the tj executes read operation on the same data, or we will be writing ti executes read before tj executes write. So all the combinations are there: write, read, write. So this all conditions are satisfied, then only we will be drawing an edge. So we will just have an example here so that you can clearly understand. So here, okay, this is TI, this is two transactions, these are the vertices, this is the edge I was talking about. So we'll be joining this edge of, all the instructions TI. So we suppose you have a graph like this, and if you have only one edge like this, that means that all instructions of TI is executed. All instructions of TI are executed before the first instruction of TJ is executed. That is why there will be only one edge present there. So as you know that in precedence graph, if there is a cycle, then S is non-serializable. If the precedence graph doesn't have any cycle, then you can say that that schedule is serializable. So let us see this example here. So in this particular schedule S1, we have three transactions T1, T2, T3. What does it mean? We will be having, there are three transactions present in this schedule. So we'll be having three vertices of this graph. So we will be forming one vertex for T1, T2 and T3. So three vertex will be there. Now what we do is here, first operation is read A. So read A in T1. So when you see here, if you see the read operation is not followed by any write operation. We need to see the same data set. So read operation in the next in T2 it is read B, in T3 it is read C. There are no operations which is having A, operations on A data item A. That means that read A, there are no subsequent writes or to this data item A. So that means there are no edge connecting that one in this one T1. So we are just this transaction, there is no edge, we are not connecting anything. Next, after this read A, we are having the transaction read B. So when you see this transaction read B, the next one is read C. So there is no write for B. So there are no new edges in that one also. Next transaction operation is read C. So in read C, if you see here, there is no, the next operation here coming is write B. There is no write to C. So there is no edge which is, no new edges in that one in transaction T3 also. Now next comes write B. So in write B, you just need to see what is the operation which is following B in that one. So it is write B. After this write B, you can see that there is an operation which is read B. It is read by, so write B is followed by read B in transaction T3. So you can see this write B is followed by read B in transaction T3. So we can add an edge from T2 to T3 because read B is here. Now after read B, we can see here this write B. After write B, now we have write C is there. So write C, you have to see whether there is a read operation. For C, the read operation of C is there. So if you see here, there is a read operation of C which is coming in transaction T1 after this write C. So we can add an edge from T3 to T1. So write C, after that read C is coming here. So add an edge from T3 to T1. Now after this write C, which operation is coming? We have write A. Now write A, after write A, you just see read A is there in transaction T2. So we have to connect T1 to T2 because there is a read operation. So there is an edge from T1 to T2. After read A, now we have this one write A, then read A is there. Then after that we have write A is there. So in write A, you have to see whether there is any subsequent read A is there. So there is no subsequent read for write A. So there is no new edges there. Now after this we have write C. So if you see, there is no subsequent reads to C. So there is no new edge. Now comes write B. So in write B, there are no subsequent reads to B. So there is no new edges. So we have formed precedence graph like this. The first one is from this one. This is the order in which we have drawn it. So the precedence graph, if you see here, the thing is when T2 to T3, then T3 to T1, and T1 to T2. So if you see this graph, it is cyclic. The direction of this graph is cyclic. How did you get this graph? By all this instruction. So we have actually joined first T2 to T3, then T3 to T1, and T1 to T2. So that is how we got that graph. In this graph we got it. So now we can see that since this graph is cyclic in nature, this means that schedule S1 is non-serializable. So we have seen the schedule S1. So this schedule S1 is non-serializable because the graph which we got is cyclic. Now let us see another schedule S2. So here also we have three transactions, T4, T5 and T6. Now let us see the first operation, that is read A. Now for read A, we just need to see whether there is any subsequent write operation. So there is no subsequent write operation to A here. There are no new edges. Now in read C, next one is read C. So there also no subsequent write operation in C. So no new edges are there. Now in write A, we can see that write A, we will be seeing whether there is any subsequent read operation of A. Okay, in write A, we can see that read operation is there in transaction T5 subsequently. That is read operation is there in T5 after this write A. So T4 and T5 to be joined. So T4 to T5 we will be joining with an edge because there is a subsequent operation. Now here we will be seeing read B operation. We will be checking whether there is any write operation for B. So here in read B in T5, this is subsequently no subsequent rise to B here. There is no subsequent write for in this one in transaction T5. So now let us see the next one. Next operation is write C. So from write C, you will be seeing whether any read operation is there. Yes, there is a read operation here. You can see here read C is there. So we have to connect T4 to T6. So T4 to T6 will be connected by an edge. Then after this one read C, we have write B here. So write B operation will be seeing if there any read B operation is there. Yeah, it is there. Now if you see in T6 there is a read B. So from T5 to T6 we'll be joining the graph T5 to T6. There will be an edge. That is write B. Then we will be now next is write C. After read B we have write C, and let us see if there is any read C operation. There is no read C, so there is no new edges. Now next operation is write A. Write A, if you see there is no subsequent reads to A, so there is no edge. Next one is write B. There are no subsequent reads to this B, so no new edges. So we can see here we got three edges. One is from T4 to T5, another one is from T4 to T6, and another one is from T5 to T6. So we got three edges, and we will see the final graph is like this. We got like T4 to T6, then T4 to T5, T5 to T6. So here in this particular graph, we can see that this graph is from T4 to T6, and from this is not cyclic. The graph is not cyclic. So the precedence graph for schedule S2 contains no cycle. That means that this schedule S2 is serializable. So this is how we'll be finding how a schedule is serializable or non-serializable by means of precedence graph. So we can test serializability by means of precedence graph. So in this particular case, the schedule S1 is non-serializable and schedule S2 is serializable. Why? Because schedule S1, when we have checked the precedence graph, it was cyclic, so it was not serializable, and the schedule S2 precedence graph we got it as acyclic. So this is not cyclic, so we can say that this schedule S2 is serializable. So this is how we will be checking for the conflict serializability. I hope you understood the concept of conflict serializability and how we can check for conflict serializability. Thanks for watching. Thank you all.